So, hi everyone. First of all, I wanted to tell you that now I work for Cisco, but I want to work in Pedro's Gamma company. He embraces failure, so that's good for me. So, I'm delighted to be here today to talk to you about one of my latest and greatest passions. They're called the future of energy grids, or smart grids. I'm not going to tell you what they are right now. We will unveil it together as we move along the presentation, okay? So, we all recognize that in the last decade, we were very, very privileged to see the dawn of the internet. We have seen also the explosion of mobile communications. These are major technological revolutions that will be written in the history books in some decades from now, and we are privileged enough to live them. Now, there's a third technological revolution coming on. If we live for the next decade, hopefully we will be again privileged enough to see it. So, how did it all started? How did the smart grid or the energy grid started in the first place? It all started with these two fine men, Nikola Tesla and Thomas Edison. They were the first to build, create, and commercially exploit companies that produced electricity, companies that distributed electricity, and they sold electricity in the 1880s to some UK neighborhoods and some neighborhoods in downtown New York. Now, it was very simple. We just have some factories, we generate electricity, and we sell it. Along the 20th century, we have seen an explosion in both number and size of electrical companies. We have seen how they cover the whole world. It's so trivial today, so natural to just plug in an appliance in our houses. Even though they're so big and they completely cover the world, they're very simple in their concept. They all have big but very few generation plants, either nuclear plants or dams, you name it. Then we have the transmission, very high voltage transmission of long distance electricity. Then we have distribution, lower voltage, smaller distribution and more local distribution of electricity. Then we just deliver that to consumption. We have in the first place unidirectional flow of power and very poor and limited communication capabilities. These segments here, they work in silos. The distribution does not talk to the generation and does not talk with the transmission, and the consumer definitely does not talk with the rest of the grid. Because the data network is just there in the transmission and in the generation mainly. So this has been working fine until now. Why change it? Well, we do have some challenges, both from the operation side and from the environmental side of the picture. From the operational side, we want telecontrol. What does this mean? I told you that we have generation and distribution. In Portugal only, and I'm talking only about Portugal, we have around a few dozen generation plants. Then we have hundreds of transmission substations. Then we have tens of thousands of distribution substations. And then we have millions of 6 million houses plugged into the electricity. So very simple concept, very huge in scale. Now, we want telecontrol to control each and every one of these substations, so we don't have to physically go there to operate it, change the parameters, and so on. We want to take that remote control down to the consumer. Can you believe that nowadays, in the 21st century, in the era of telecommunications, there's a person physically that goes to each and every of your houses just to read how much you consumed electricity so you can be billed appropriately? That's not of the 21st century. So we want to take that remote control down to the houses with smart meters. We want something that is called demand response, and this is just to avoid waste. So if I'm an electrical company, and if I have excess of energy, I want to tell my customers, hey, Why don't you plug your laptops, your electrical vehicles, your dishwashers, your washing machines, whatever, just so that I can avoid wasting this excess of energy that I have now? Or the other way around, I have a shortage of energy. Why don't you plug your appliances and your dishwashers tomorrow and not right now? That is consumption talking to generation. That's demand response. From the environmental point of view, we need and we will have a lot of renewable energies, sources. And that is very important for the grid because it's either sunny or rainy or there's a lot of wind. The power coming from renewable sources is varying in real time. We want to take those renewables. We want to take those renewable sources down to the consumer. So the consumer is not just a consumer, it's a micro generator. I can have my solar down there in my house, buy and sell electricity to the grid. And finally, we will have electrical vehicles. And for the first time, this means storage, distributed storage of electricity, which was very hard until now. Millions of cars with their own batteries out there are rolling out. So how do we face all these new challenges? We basically change the paradigm. And that means creating a smarter grid. The first thing we have to do is this network here, the data network, it goes to each and every one of the parts of the grid. Generation, transmission, distribution, and down to the consumer. Now the consumer talks with the rest of the grid. They all talk to the operations center. And not only that, we have a new element right there, which is a new layer of business, a new market, and I will be talking that in a minute. Fortunately, Portugal is not lagging behind these technologies. Our electrical company has put in place a pilot called InnovGrid. It's a pilot of 50,000 houses, mainly in Évora, but not only, where they have put down smart meters. They call it energy boxes, one for generation, one for consumption, so that people in the house can see in real time how much they're consuming, which appliances, how much they are generating and selling to the grid. Not only from the houses, but because it all has a connection to the internet, you can see it wherever. The smart grid compares to the traditional grid a little bit like the good old analog phone compared to the iPhone. It's not about the technology. It's about the new market that it's out there and that allow us to create a whole new variety of applications of businesses that we can put on top of the iPhone or the smart grid, and we can make markets and businesses out of it. In the smart grid, we have, for example, and these are just examples, you entrepreneurs would find out a lot more examples than I would think of. Mobile accounting, for example. Right now, my electrical account is tied to my apartment. But what if I take my electrical car and I go to my friend's house and plug it in to recharge? I want an application to tell that smart meter, hey, do not bill this to my friend's account, bill it to my house, my apartment's account. We can have prepaid electricity. We have that in the mobile phones, don't we? Why not here? We can have our own storage of data, of energy, for example. Because the utility is interested in selling cheaper, at a cheaper price when they have excess of energy, and buying at a higher price when they are short of energy, we can store for some hours or days the electricity and then buy it and sell, like a stock market. Just instead of buying and selling stocks, we're buying and selling electricity. Now, in the very end of the smart grid, there's not only technology, there's people. They're smart people. And smart people in two ways. One, that they can exploit this new layer of businesses. And this is a call out there for all entrepreneurs. There's big bucks to be made here. And also, there's you can increase and help increase the impact it has on the environment. Just because we're managing this, the energy more efficiently, in avoiding waste, we can reduce the waste of energy and the energy needs by up to 20%. So when you're at home, when you don't need to have the lightnings on, just please turn off the lights. Thank you.